At first glance it looks fine, but something feels off. No response. Sometimes it works, only when you hit the body. Sometimes it turns on, sometimes nothing. The zoom light works randomly. The main lid works only with charging, and sometimes it doesn't charge at all. This means there is a hidden connection issue inside. Let us fix it properly. Start from the charging port cover. Remove the front lens ring. Then take out the zoom lens. At first, it looks like this part should unscrew. Tried the usual twist, but it doesn't. So there must be another way. Keep watching. Working it loose, gently. A few tries later, carefully lift the front LED cover. Remove the power button rubber. Now the whole board can slide out. But what if the wires are still connected when the board slides out? No power at all? Since the board is out, let us try the first method to open the zoom. Most flashlights are threaded, but this one is not. It test press fitted. You have to push it from inside. A few gentle taps, and it comes out. Another way to open it if the wires are intact, push both parts apart gently. The metal lid module comes off easily by hand. No threads, it just pushes in. Carefully remove the zoom LED module. Push the metal housing out. Both wires were disconnected on opposite sides. That's why the zoom LED wasn't working. The O-ring is actually torn, but it is still important. It smooths and slows the zoom movement, keeping it stable instead of loose or fast. I'll take care of that during reassembly. These pins should be firmly soldered to the board, but the negative one is almost loose. And the positive pin is actually broken, not just loose. When I press here with a tool, the main light turns on, probably caused by repeated hitting or forcing the power button to make it work. Then the board completely separated from the battery, confirming a weak factory soldering issue. The battery has no markings, but it seems to perform well in use. Solid build. Worth fixing. With a few simple improvements, it can last much longer. Good board design but weak solder joints here. I removed the broken positive contact from the board and cleaned the soldering area. But I noticed another issue. The positive terminal is too short now. It doesn't reach the board. So I gently heated it in place to extend it slightly so it can reach the solder point again. Even if they are very short, just use wires. First, I corrected the alignment. Then I soldered the positive and negative points. Factories don't build things to last forever. But if you build it for yourself, you take your time to make it right. The charging port had weak soldering, so I reinforced it with extra solder. Simple tool but incredibly useful for small repairs. Match plus to plus and minus to minus. The main light is working now. But we're not done yet. For this, I am using wires from an old Samsung earphone. They are flexible and built to handle constant movement. The original wires are not designed for movement. They break easily and can't handle repeated stress. And there is no reinforcement at the solder joints, which is the most sensitive point under movement. So I cut 2 new wires to match the original length. Battery out first. Sapphire before soldering. Installing new wires. Positive. And negative. I used Samsung earphone wires, but any good flexible, durable wires can work as well. Now I am connecting them to the LED module. I'll tin the wire ends first. Give it time so the solder fully flows through. The heat removes the insulation and gets them ready. Red is positive, black is negative. Polarity is important, must be correct. Old residue still on the pad, so I removed it before soldering. Just a note, this is how the LED is replaced if it burns out. Let us test it now. LED voltage is about 3.5 volts. All lighting modes are working so far. I'm now removing the wires from the board. Time for the final reassembly. This step is very important. Take your time here. Don't rush this step out. I am using hot glue here, but it's optional. Now reinstalling the LED module into the metal heat sink. Wires must go through the opposite holes properly. These LEDs get hot. Without a heat sink, they won't last long. Now installing the lid diffuser ring back in place. Noticed I forgot the Zoomable ring. Just a reminder. The out ring keeps the zoom smooth and controlled. It was torn, so I glued it with T7000 and secured it back in place. Ideally, the O-ring should be replaced each, but I did not have a new one available. Now everything is ready to go back together. Now reinstalling the metal heat sink onto the moving soon barrel. I'll lay in the reflector in the Zoom module. Make sure the O-ring stays in place. This part presses into the tube. I used a bit of hot glue to fix the board in place to prevent movement. As you can see, a clean design. Most modern flashlights are like this. Now I insert the board and battery assembly into the tube from the back so it comes slightly out from the front. The board can slide out in both directions to allow soldering the Zoom LED wires. Now soldering the Zoom LED wires. Red is positive, black is negative. A polarity matters. Be careful not to touch both terminals at once. I reinforced the wire solder joints. This is where the wires usually break. This part can be confusing. Watch closely. Reinstalling the power button cover. It may look assembled, but it has not locked in yet. This part presses into the tube. Now I'm getting ready for the final fit using a bottle cap. I'll press the metal heat sink into place. Gently tap it until it seats in place, so it locks inside the tube while the zoom still moves smoothly. Reinstalling the zoom lens. Securing it with a retaining ring. The side cover only installs once the board is correctly aligned inside the tubes. Reinstalling the side light cover. Reinstalling the charging port cover. Make sure it aligns with the connector opening. Now it works smoothly. Everything feels solid. Worth fixing. Short use helps extend LED life.